All right, what's up, everybody? We're back now. This is going to be the final section, and now we're going to talk about the non-renewable energy source. Right. Last time we talked about the BTU, and then comparison and all that. So now I'm going to ask, what are the major non-renewable sources? Right. We already talked. There's three major ones, right? Fossil fuel, and then coal and uranium. So here, apparently, they want to split up fossil fuels, which is fine. We're gonna have four: crude oil, natural gas, coal, and uranium. So real quick, I want to talk about just a little bit of each as an introduction, and then probably later on in class we're gonna go into a lot more detail, especially on how does the plants work and operate. Right now we're just talking on the energy side. So here on the left-hand side under non-renewable sources, we'll look at oil and petroleum products, right? And obviously you can see there's a lot of subcategories of, refining it, import, export prices, gasoline, diesel, heating oil, which is all, subcategories of oil and petroleum. I'm gonna leave this up to you to read the little more details and, kind of get an idea of, what does a gas industry look like, right? It's pretty important. So, real quick, what is crude oils and petroleum products, right? Pretty much crude oil is just hydrocarbons. These were formed from dead animals and plants 300 million years ago, and then they kind of got smushed into earth, right? And they got smashed together and kind of decomposed into oil or fossil fuel as we know it, right? And then this is where we come in and we drill deep down and kind of find them and pump them back out and use it for what we want to do, right? Now, one thing some people never realize is you can't just take oil from the ground and stick it directly in your car. Okay? Oil from the ground is called crude oil. From then, you get to take it from the offshore oil rigs or the barges, whatever medium you're using to transport, a pipeline per se, and you got to refine it, right? That's what a oil refinery does. It takes crude oil and refines it into actual usable products, right? So here, this kind of picture, your standard 42-gallon barrel of crude oil, right? What can we get out of it? So 20% of it is going to be from gasoline. 20 gallons is gasoline. 2 of them is hydrocarbons, heavy oil, and then some other stuff, right? And jet fuel and whatnot. So not all of it just goes straight to gasoline, which is what most people think. Okay. And of course, you could go down to, refining crude oil, and then I guess, dang, they don't really talk much about it. I thought they would, right? There's a whole entire process of refining crude oil that chemical engineers use, and then that would say, what percentage or how many gallons of what come of gasoline versus jet fuel and other stuff comes out, right? So here, that's all this down here. If you want to check it out, you got gasoline. I'm sure you guys have been to gas pump. It's a regular mid-grade and a premium, right? So, hey, just if you guys didn't realize, the only difference with these two are these numbers, right? 87, 89. And unfortunately in California, I don't know why they even have this picture, is we don't have 93 here. We're only 90. The max we have is 91 because somebody said 93 is bad for environment. So bandwagon it up and then it gets banned from California. All right. So what do these numbers actually mean? These are called octane rating. The only reason why we use these numbers is it has nothing to do with efficiency. It has very little bit to do with how clean the oil is. What most of it is how well refined it is to a point to where is it going to damage an engine or not, right? And here it says all it really does is it reflects the anti-knocking properties of gasoline. So what it means is if you have a super high performance engine that has a really high compression ratio, you want to use a high grade premium gas so then it doesn't pre-detonate and makes your engine knock and kind of tears it apart. So if you have a standard Honda Civic or a F-150 or basically not like a exotic, not even a sports car, a Mercedes or electric car, you're pretty much okay with 87 regular, right? Anybody tells you get premium to clean your engine is full of crap. Don't listen to them. Just literally get 87 octane. To be honest, unless you're driving a Ferrari or like a $300,000 car or maybe $200,000 Mercedes, you could probably even get away with regular. Any car nowadays will say they need premium. They could probably run in regular and then you'll just get like less horsepower, right? Which is perfectly fine, right? So, of course, if your car says use premium, but don't fill up a premium thinking, oh, I'm gonna save money or something. You're straight being a donkey there. Okay. Then you got diesel fuel here if you want to read that. Heating oil here, which really we don't use, but if you're kind of living out in the boonies, yeah, heating oil is probably a lot better than running a gas pipe all the way down to you from the major pipeline in the city or something, right? So read it on your own accord if you want to. Next, we have hydrocarbons, right? Gases and liquids. This is it's weird. It's not natural gas. It's a little bit different. So this is where you have to take crude oil and natural gas and kind of refine it and mix it with other chemicals to produce an end product, right? Here, there's different types. Ethane, propane, right? You guys probably heard that. Also propane and propane accessories, right? Butane torches, natural gasoline. I've never really heard that, to be honest, right? Ethylene, propylene, these two I've heard before as well, right? So basically, these are just like different types of gases that we use for, like, propane we use for grilling, right? Butane we use for torches for cutting metals, right? And so it's just a different type of gas that we can use, right? Then we have natural gas. What's the difference from hydrocarbon gas liquids natural gas? We don't have to refine natural gas. Natural gas actually comes straight out from the ground, right? So here it's literally just deep beneath the earth, and then you just pump it out. Or you probably don't need to pump it out. You just drill a hole and cap it, and then it'll come out on its own because of the pressure, right? And then, again, how's it formed? Millions of years ago, you had a bunch of creatures play around and die, and then the earth kind of, built on top of them, and then they get pressurized and turn into gas, right? So here you can see right here, you get the sand and the rock and all that, and down below is all the oil and gas deposits, right? What's funny is crude oil and actually natural gas kind of they're found in the same place, I believe. And long time ago, they didn't really know natural gas. They didn't have a good way to harness it. So they literally just burnt it. They're like, we just want the crude oil, all this natural gas, just burn it on site, just whatever. It's kind of wasted product. Then later on they realized, oh, we can actually use this, so they started harnessing that or capturing that as well, right? Blah blah blah. So yeah, it's pretty much I picture what it looks like. This all they're doing, they're just trying to find oil. They're not even drilling it yet. Okay. So again, read this. You can read a lot more if you really want to about natural gas. Where does natural gas come from? I actually want to know, right? 26% comes from Texas. Surprisingly, 18% comes from Pennsylvania. Look at that, right? Oklahoma, Wyoming, Louisiana. Okay, I can see that. Okay, so now let's go ahead and coal. Right. So, here in California, you're not going to find coal. We stopped using that years ago, right? Because it's kind of bad for environment and all that. But you go down and pretty much anywhere else, coal power plants are kind of the go-to. Why? Because coal is super cheap, and the only problem with coal is a logistical nightmare because it's so heavy. It's very hard to move. So typically, coal power plants are built relatively close to coal sources, like the Appalachian Mountains on the East Coast. There's a bunch of coal over there, and the Rocky Mountains. In the Midwest, there's a bunch of coal over there. So a lot of coal plants are built around there. They're also built around major rivers, like the Mississippi River that goes down the middle of the United States. A lot of coal power plants are built on that because it's actually pretty easy to ship coal down the river. You just put it in a barge and let it just float downstream, and it's naturally going to arrive at the coal power plant. Okay. So where does coal come from? Again, lots of plants, millions of years ago, fishies and stingrays kind of having fun, and then they died. And then, like, the earth decided to bury them naturally, and then they got smushed again and then turned into coal, right? So here, coal is combustible black or brownish rock with high amounts of carbon or hydrocarbon, right? And this is something I didn't really know until now. There's different types of coal. I always thought there was only just one, right? And the only difference between these different types of coal is the percentage of carbon, right? The more carbon you have, the more energy is stored. Pretty much the energy inside is the actual carbon, right? So here, this 86.9% carbon, that's super good, but I think there's only very little amount of it, less than 1%. Most of it's this middle grade right here, okay? So that's good to know. So again, coal is everywhere. It's very cheap. We love it. Bad for environment? Absolutely. Do we care right now? Depends where you are. California, yes. Everywhere else, no. China's actually the worst about it. They actually give two craps less about the environment, and they just burn coal like crazy, and that's why there's a bunch of pollution and bad stuff going on over there, right? In regards to the environment. So last one we're gonna look at is nuclear. Here, nuclear energy is pretty much taking atoms and splitting them apart, and then a bunch of energy is released, right? The sun itself is pretty much a gigantic nuclear fission and fusion reactor, and it's pretty much going on nonstop, right? Here, around 1930, probably 20s or 30s, scientists realized that they could actually make a artificial, they could induce a fission reaction and release a bunch of energy, right? And later on we'll actually talk about how does it actually work. Here we get nuclear fuel, which is uranium. There's a nice little picture right here. Oh, I guess we can't open it. That's fine. Open a new tab. Zoom in. Good. There we go. So how fission splits up uranium. You had uranium-235. You literally fire a neutron into it, and it splits up into two lighter elements, two extra neutrons, and then energy. And the thing that causes a chain reaction is this neutron will then hit another uranium, this neutron will hit another uranium, and then it'll kind of spread like wildfire and just create a chain reaction, right? The only difference between a nuclear bomb and a nuclear reactor in a power plant is a nuclear reactor at a power plant would control the amount of neutrons that come out and hit other uranium molecules. In a nuclear bomb, you literally just let it go full blast and blow everything up. Okay. All right, let's zoom out a little bit. So, yeah, you see, I knew this, but this is something a lot of people don't realize is all nuclear power in the United States used to generate electricity. We don't use it for anything else, literally, because it's a little too dangerous, and the overhead economy scale so it doesn't really fit well with small operations. So you only want to ever use it for large operations, right? So I think that pretty much is a good stopping point. We kind of just touched base on all the different non-renewable energy sources, and then probably now we're gonna go and revisit all of these different oil, hydrocarbons, natural gas, coal, nuclear, and also hydropower, and talk about the traditional energy sources. How does the plants work, right? Because we understand the energy sources now, but how do we actually convert nuclear power, coal, gas, water, pressure into electric energy? And that's what we're going to talk about coming next week and so on. Okay, so hopefully you guys like this session of online lecturing. Again, let me know some feedback. Do you like it? Do you not like it? Should we change stuff? The light's too bright, the microphone's too loud, am I talking funny, all that stuff. All right, and if you guys like this and get some good feedback, we could probably start doing this on a more constant basis. Okay, so you guys have a good weekend, and we'll catch you later. Come watch